Today, we're going to talk about some things that are near and dear to my heart and are probably also near and dear to your hearts as Android developers. Things like handling lifecycle events, maintaining view state, persisting data. Don't you just get warm and fuzzy inside when you hear those things? No matter when you started working on Android, whether it was way back when with Alpha Beta Cupcake or more recently, you probably have dealt with some challenges around these things. And it's common challenges like these that we all encounter every day building apps and libraries that have led to the popularity of clean architecture as a concept in the Android community. And of course, has also contributed to the interest behind the new Architecture Components project released this year by Google. Now, new frameworks are great if you're starting a new project. However, not all of us are in that type of a luxury position. And so you might be asking yourself, well, great, but how can I take advantage of some of these new tools working on an existing code base? And how can we best leverage the power of them without totally rewriting our app from scratch? And so that's what we're going to talk about today. My name's Chuck, and I lead the Android team at Button. For those of you who aren't familiar with Button, we build a set of mobile SDKs for Android, iOS, and mobile web. And with buttons, you can do things like allow users to book an Uber directly from your app, or book a hotel on hotels.com, or even purchase tickets on SeatGeek or Atom. And the best part is, every time somebody makes a purchase, then you get a commission. So if any of this sounds cool to you, and you're interested in becoming part of the Button marketplace, come talk to me after the session. So who can tell me what these three movies have in common? Just shout it out. They were all made in the 90s. That's a very good observation, but that's not what I'm looking for. They've all got really great actors in them. So I'll give it away. They all start with the end. And so that's what we're going to do with the talk today. We're going to start with the end of the talk and work our way backwards. So here is my version of a fully functional, clean architecture using the new architecture components. Now, there's a lot going on here, and you might feel a little bit like Edward Norton's character at the end of Fight Club when he tries to rid himself of his alter ego by any means necessary. Okay? It's like, wait, there's a controller, there's a presenter, there's a view model, there's a bunch of things going on. Like, what's happening right now? Now, on one hand, if you're very impatient, you can just take a picture of this slide and leave and go see another talk. I won't be offended. But if you want to figure out, or if you want to learn a little bit about how I arrived at this conclusion of an architecture, then that's what we're going to talk about today. And so we're going to kind of break it down and go through the process of building it up until we get to what you see on the screen right now. So let's dive in and have some fun. Now, when it comes to clean architecture, I feel like these are one of these topics in Android that's very similar to testing and documentation. It's something that maybe we pay a lot of lip service to, and maybe even when we start out a new project, we have the best intentions of following some framework or pattern or set of principles. But then over time, as things like deadlines and scope creep start to impact our development process, what started out with the best intentions may instead wind up looking something like this, or maybe even something like this. And sadly, over a period of time, without proper care and maintenance and refactoring, your code base may start to look like this. Whereas on the other hand, we actually want something that looks like this. Or maybe if you're going for more of a modular architecture, something like this. Or finally, something like this. Now, this particular photograph reminds me of an interview I heard with an author on NPR where he was doing a worldwide book tour, and when he was traveling to Japan, his publicist went ahead of time and made all the arrangements, set up the accommodations. And so when he came, they already had the place where they were staying, which was similar to this, more of like a traditional Japanese architecture. And once the author arrived, the publicist had been there for some number of days or weeks, and he was just blown away. He walks in the front door and just looks around, and it's pristine, beautiful, clean, but the room was basically entirely empty. And then except for on one wall, right in the middle of the wall, was a table, and on it was a vase with the most beautiful bouquet of flowers he had ever seen in his life. And he was just like, I don't even understand. What is this? And the publicist replies, this is elegance. And so if we think about that same principle and apply it to software development, elegance in design is really a lack of unnecessary complexity. And so what are the goals that we're trying to achieve with something like clean architecture? Well, for me, it really breaks down into three categories. Separation of concerns, the idea of having a layered architecture. Number two is the ability to synchronize the state of your app. And number three is testability. Now, going back in time a little bit, looking at this from a historical perspective, in the 1960s and the 1970s, software systems really didn't have the concept of a graphical user interface like we have today. And so, as GUI systems started to become more popular in the 80s and 90s, they drastically improved user experience. However, they also introduced a whole new set of challenges for us as developers. How do you handle dynamic and asynchronous user input? How do you keep your view state in sync with the state of your underlying application? And how can you best separate your presentation logic and your domain logic so the two don't become polluted? And so if you've never read this particular series of articles written by Martin Fowler in the mid-2000s, I encourage you to go back and do so, if for no other reason than to realize that the idea of clean architecture is, these are not new ideas in software development. These are things that we've been thinking about as a community, as an industry for a long time. And you can see here, this particular one is dated 2006, and as we learned this morning in the keynote, the first preview release of M3 of the Android framework didn't even come out until November of 2007. So these ideas predate the Android platform itself. And so it wasn't really until late 2014 that we had the idea of clean architecture and how to best apply it to Android really become popular. And it's become increasingly popular over the last few years and leading up to the new architecture components. And I simply couldn't move past this slide without also pointing out this awesome graphic of the MVP bling that the Android is wearing there. Actually, I think I'm going to have that custom made for myself. So the fact that these are the kinds of things we're talking about now as a community makes me happy because it's a sign that the Android ecosystem is starting to mature. And so what I really want to do in this talk is take a look a little bit back through the history of software development and see what lessons can we learn from these classic software design principles. And then, as a second part, how can we best apply them to modern Android development? All right, so let's look back at our goals here for clean architecture. The first one being separation of concerns. And really, like I said, this is the idea of building a layered application, having your view layer separate from your presentation layer, separate from your domain layer. One of the biggest advantages here is that if you then need to make a change to any one of these, ideally it won't require you to make changes necessarily to the other layers. And so there's this idea of maintainability that makes it a little bit easier to manage our system as it evolves over time. We also have the idea of state synchronization. Now, a lot of us might think there's only one state that's in your app at any one time, but I'm here to tell you there's actually three. And it's our job to keep them all in sync. And really the question is, which one at any given time is the source of truth? Well, I can tell you what the source of truth is from the user's perspective. That's whatever's on the screen at that time. Well, but from your business logic's perspective, that's going to be whatever's currently stored in memory. And then maybe if you have other clients accessing the same data, the source of truth for them is going to be whatever's on your back-end server. And so really one of the biggest challenges for us is how do we synchronize these three states and make sure that we don't have multiple sources of truth. And so this talk is really going to focus on the synchronization of screen state and session state, whereas server state is a whole other topic that we're not going to get into today. And then finally, testability. I have a confession to make. Every talk I give is really just a Trojan horse to talk about testing in one form or another. And so we're going to spend some time on that as well. And really, when we're talking about testability in the Android world, I feel like one of the biggest things that you get from clean architecture is the ability to separate and encapsulate your Android dependencies in the view layer. And that gives us pure JVM style testing for our presenters and our domain models, and then we can use whatever framework we like to do our integration and our UI tests on the view. You might be familiar with this classic diagram from Mike Cohn's book in 2009, Succeeding with Agile, which kind of lays out the idea of a layered testing strategy. And so you can see here we have the largest chunk of our tests as unit tests, moving up from that in complexity and also in cost, is our service or integration layer tests. And then finally at the top of the pyramid, where we have the fewest number of tests, is our full-on end-to-end UI tests. And what you see is that as you move up, the tests both slow down and become more expensive. Well, so I really like this idea as a concept, and so I built my own version of the test pyramid that we could apply to Android and tried to put in there where I think some of these different tools we have available today slot in. And so down at the lowest level, you have pure JUnit and Mockito for your unit test. This is what you're going to use on your presenters and your models, provided we can keep all the framework dependencies out of them. Moving up the pyramid for the integration or service level tests, this project is less popular than it was when it first came out, but I think actually Roboelectric slots in here quite well in that it gives us a realistic simulation of what would happen when our app or our library interacts with the framework without the overhead of deploying on an emulator or a device. Another approach here would be to use the instrumentation test framework minus the espresso bits for UI testing, and you can spin up an activity, but then you have to deploy it on an emulator or a device. So those are kind of two approaches you can use for your integration tests. And then finally at the top, and again, I can't stress this enough, this should be the fewest number of tests you have in your system because they're going to take the longest to run and they're going to be the most difficult to maintain, but this is where we can use one of the UI testing frameworks that we have. Now, if you're reading up on the docs for testing that are provided on the Android developers page, you may come across this one that says something about building instrumented unit tests. I'm here to tell you that this is actually a lie. They're integration tests. Because a unit test is not going to deploy on an emulator or a device. It's not going to interact with the framework. A unit test tests your code and your code only in isolation. But still an effective strategy for integration tests. Hopefully somebody will fix that typo soon. So now that we have an idea of what our goals are with clean architecture and maybe a little bit about how to achieve them, let's take a look at the ones that are out there. And so there's a number of different GUI or graphical UI architectures that have become popular, and especially in the Android community, these are the ones that we've been talking about how we can best apply them to Android projects. And so you have things like MVC, MVP, MVVM. Now, I'm not here to suggest that these are all exactly the same, but they have way more in common than they have different. But there are important subtle differences, especially with the flow of information and how these different components communicate with each other. And there's a lot of confusion about, what the different names mean and where they can be best applied. And so as we're kind of teasing this apart a little bit and looking at some of these architectures in more detail, I think it's helpful to have the idea of a case study or a sample app that we can talk about in the context of. And so we're going to use a simple login app. Any Phineas and Ferb fans out there? No? Nobody? Nobody else has kids? All right. And so we have a simple login app that literally does nothing except for allow a user to log in. And so you can enter an email and a password, and then when you click on the button, it sends that through your system, compares it to some data store. If you get a valid user, it displays that user's profile on the screen. If not, it displays an error message saying invalid credentials, try again, that sort of thing. So how might we approach building this simple login app using clean architecture ideas? Well, the first architecture I want to look at is called supervising controller, which is also now popularly referred to as MVC, or model view controller. Now, this first became popular with Smalltalk in the 80s, which then evolved over time into some form in Objective-C, and is still remnants of it are seen in iOS today. And so really we have our three primary components here. We have our view, our controller, and our model. When UI events come in through the view, we're just going to push those off onto the controller. for example, clicking a login button. The controller is then going to invoke the model and say, okay, here's these credentials I just received. Go get a user that matches these credentials. And then what happens is the view is going to pay attention to what that model's doing and observe any changes in it that then is going to update the display based on the result of passing those credentials into your domain model. And so I think this is actually a really great example of where data binding can be used, in that it gives you that direct connection between your view and your domain model classes. However, and so what we have here is essentially a one-way unidirectional flow of information throughout our code base. And so I just want to speak specifically to the data binding expressions for a minute. So many of you have probably used the data binding library in Android, and it involves putting something like this into your XML code so you can bind it to the model, and then you can also automatically populate your text fields with changes that happen in the data model. But there are some challenges here too around, okay, well now write a unit test for this stuff. You really can't. And this is a pretty simple example, but you can imagine as your expressions get more complex, it's going to be more important to test them, and this won't really prevent somebody from fat fingering and maybe putting the last name ahead of the first name or something like that. And so while this gives us a very clean flow of information, it also introduces some difficulties around testing. The second architecture I want to take a look at here is called passive view, also popularly known as model view presenter. Another name for passive view in some of the papers that I researched this in was also humble view, because the idea is you make the view as simple as possible. And so in this one, you're going to not have any dependency between your view and your domain model the same way that we had with MVC. So the flow starts out the same. Events come in through the UI. We push them to the presenter now instead of the controller, and those get pushed down into the model where we interact with our business logic and find the user. But now, instead of the view observing changes in the model, the presenter is going to act as a go-between that passes information in two directions. But we don't want our presenter holding on to a direct reference to our view, especially if we're trying to eliminate framework dependencies from that half of the code base. And so we introduce this idea of an interface in front of the view, which then the presenter actually calls back through to tell the view what to display once the model has completed its work. And so the state sync strategy here is what I would call flow synchronization. And so you have a two-way flow of information with the presenter acting as the middleman. And so here's a simple example of what that presenter might look like, at least for the login click events. You'll have the raw input coming in from the view, and I gave away a little bit about what's coming up later by calling the view the controller here, but hold on, we're going to get to that. And then, so the presenter is responsible for doing things like input validation, and then if it has something that's valid, it considers valid input, then it's going to pass that off to our model, in this case the loginator, which then it looks at the result, and depending on the result it gets back, it tells the view what to display through this controller interface, which we're going to talk about. So the last architecture I want to spend a little bit of time on here before we do our comparison is that of the presentation model, also popularly known as model view ViewModel. And so in this particular case, again, very similar to what we've seen before, we have our three main components. The flow of information incoming is the same as it was before, but now the way that the view model and the view sync up is slightly different than what we had with the presenter. The presenter, we don't have a presenter pushing commands back to our UI. Rather, we have the UI observing changes on the view model. So it bears some similarities to what we saw with MVC and MVP in that we're using more of an observer pattern, but rather than directly observing the data model, we're observing this intermediary of the view model. And so synchronization here, I think, can be summarized as the observer pattern. Now, if we look at our three architectures side by side, we get a little bit of a better understanding of the ins and outs of what each one of these is capable of. So you have the one-way flow of information with the MVC, where you have more of a two-way flow with your passive view and your presentation model. MVC is also the only one where you have a direct dependency between your view and your model. Sync logic is all slightly different, but where it lives is kind of the important part. So both the MVC and MVVM require some amount of your sync logic to live in the view layer. And so for that reason, when I'm trying to decide which one I should use for any particular project I'm working on, well, I tend to go with Kendrick. And so I really think humble view or passive view is the one that gives us the greatest flexibility as far as maintaining the different layers and then also exposing that sync logic to be able to be unit tested, which is going to be a challenge with either of the other approaches. And so what passive view does is it migrates all your sync logic into the presentation layer. Now, for simpler apps, maybe MVC or MVVM is all you need. But as your app grows in complexity, that sync logic is going to become more and more difficult to maintain. You're going to need to rely more on UI tests to verify the behavior as opposed to pure JVM unit tests. Your tests do wind up becoming a little bit more verbose with MVP because you actually have to have a fake implementation of that view interface when you're in your test environment. But for me, that's a well worthwhile trade-off and also avoids some of the tangled mess we can get into with mocking frameworks. All right, so let's say we want to use passive view. Now let's look a little bit closer at how we might apply this to the Android environment. So a lot of people, when they want to build passive view or MVP, a lot of developers will take the approach of, oh, I'll just put an interface right in front of my activity that is the interface to my view, and then have my, my presenter and my models communicate through that. Well, if we're breaking this down for the purposes of trying to find the right level of abstraction so we can better reason about our code and better, lay it out in a more decoupled fashion, well, I think that this approach is problematic for two reasons. The first being, this activity is way violating the single responsibility principle. It's responsible for way too much right now. So we've got things like the actual display of the user interface, also reacting to UI events coming in. We have lifecycle events coming in from the system. Also, by nature of being a context, the activity is your gateway to other system services like the layout manager, the location manager, so on and so forth. That's a lot going on. So for me, I think it helps to think about your view as a separate component from your activity. Now, I'm a big fan of things like compound views or custom views to encapsulate some of the view, the details of what is displayed on the screen away from this activity thing. Well, now we have a different problem. You see that view has become an overloaded term in our system. In fact, there are already a whole hierarchy of classes in the Android framework that are called views, and so I don't really want to introduce another interface in there that's called a view. And so I choose to call this the controller. Now you might say, wait, no, you can't do that. I thought we were doing MVP. You can't have a presenter and a controller. Well, really, these are just names, and I like to choose the names that give me the best ability to reason about the code that I'm writing, so that if you're talking with another developer, you can say, oh, it's behind that. If I say, oh, you just make this change in the view, and we have more than one thing called the view, that introduces ambiguity into your code base, makes it harder to reason about, and ultimately harder to maintain over time. So we have this interface in front of our activity called the controller. Great. I don't know why that slide was in there twice. Oh, but the arrow moves up and down. Isn't that cool? One more time. All right. So the other thing that this does for us is it allows us to draw a line right down the middle of our architecture and say, this half cares about Android, this half does not. And so, like I alluded to before, this gives us a huge advantage when we go to approach our testing strategy, which is for the non-Android half of our app, specifically our presenters and our models. We can do these as pure JUnit tests with a fake implementation of our controller that we can then use to verify the results of the behavior of both the presenters and the models. Then when we approach testing the half of our app that actually does care that it is an Android application, that's where we can use something like instrumentation, Espresso, Roboelectric, pick your favorite one for your integration and your UI tests. So now let's look a little bit more in depth of how we might implement this in the code. So we have our activity here, which Now we've offloaded a lot of the responsibilities, and so really all it does when it spins up is it creates, after it loads the view, it creates an instance of a presenter and passes a reference to itself. But of course, it's not passing a reference to logging activity, but rather the presenter is going to recognize it as a controller. And that's just the interface that we want the non-Android half of our app to see. And so this is all it sees, and just knows that there is a controller out there that knows how to show a user and show an error. Doesn't care that it's Android, it could be anything. Also, I said I was a big fan of compound views. That allows us to really simplify the layout that's associated with our activity. It has two views, a login view and a user view. Either we're accepting credentials or we're showing the profile, and that's it. That's all the activity cares about. Now, when we implement the login view itself, there's no magic here. It's just literally a wrapper for the email and the password input, and also gives us the ability to display an error message. We don't see it here. There's no code associated with it, but it also does contain the actual button that you click on to execute the login flow. No secret expressions, data binding buried in here that's untestable, just plain vanilla views. So going back to the presenter, this is what's going to, when there's a click event that comes passed in from the view, this is going to invoke our domain model, the loginator, pass it the input that we've sanitized or validated here, and then wait for the result. When it gets the result, it's going to either display a user or it's going to display an error. And so here's our implementation of the controller interface. All we're going to do is toggle the visibility of which view we should be showing at any given time, and then each individual view knows how to display itself. And so again, no black magic in here. We just have a property for the user. It comes in, it displays on the screen, and everybody's happy. So that all seems well and good, but there are still some things that we haven't addressed. Some very Android-specific challenges around implementing this type of architecture. And that's things like foreground and background events, or dealing with device rotation, configuration change. Also, we still have the question of how do we scope the presenter? Does it die and get recreated like the activity every time the device rotates, or does it persist in memory? And then if it persists, well, how do we know when to finally get rid of it for good? Also, we have the issue of long-running operations here. I was being very hand-wavy about the asynchronous nature of data fetches, but if we're accessing a database or making calls over the network, we might start that in one configuration and then have to find the result post-configuration change or when our app is resumed from the background. And then finally, maybe we want to cache some data locally so we don't have to go over the network every time. So what's the best way to approach that persistence? Aren't these the things that make you feel warm and fuzzy inside? So this brings us to the new architecture components. Now I have to say, when this was announced at Google I/O this year, this is the second most excited I have ever been about an announcement at Google I/O related to Android. The first was when I found out we were ditching Eclipse and moving to IntelliJ. Now, when architecture components was announced, it was introduced as Google's opinionated guide to app development. Well, I also have some opinions, and I'm going to share them with you today. Oh, and one final note, by the way, I really love the honeycomb throwback theme here. It's great to see things coming full circle. That animation was so good, I'm going to do it again. All right. So now, by this time, how long ago? Like 6 months ago that these components were all announced at I/O. I'm sure you've all had a chance to look at them, and you've seen and read many tutorials. So I'm not going to spend time talking about what these are or what they do. What I am going to talk about is how we can start to insert them and take advantage of these incremental advantages into this existing architecture that we've already built up using our classic software design principles. And so here is a sketch of not exactly what we saw at the very beginning, but sort of a skeleton of how our app is currently laid out. So we have our activity. It's not a lifecycle activity yet. That's a mistake. It's just a regular activity behind our controller interface. It talks to our presenter. We kind of enhanced our domain model a little bit by wrapping it up in a repository that knows how to fetch data either from a web service or from a local storage source. Back on the view side, rather, we have our edit texts that are used for the email and the password input, and then we have our button that the user clicks to log in. And so you can see kind of some of the responsibilities that we have on the view side and the responsibilities that we have on the domain logic side. And then we're using dependency injection to kind of make everything interact with each other nice, and so we don't have any components that are, buried inside of another app. Everything is modular and testable, or buried inside another piece. So how can we start to take advantage of the lifecycle components in this existing architecture? So lifecycle, if you remember, has the idea of owners as well as observers, and it also has states and events. And so we want to be able to take advantage of this as we move information flowing throughout our architecture. Well, how can we do that? First off, we can make our login activity a lifecycle activity, which lets the system know, hey, I'm a lifecycle owner. Well, this actually isn't even necessary anymore, because now that the API has stabilized, app-compat activity is just automatically a lifecycle activity. So you can just use that here instead. There's one other more subtle change we're going to make, which may not be immediately obvious, and that is we're going to declare our controller interface as also being a lifecycle owner. So this way, when the ViewModel gets a reference to our controller, it doesn't have to know it's an Android controller, but it will know that it has something to do with owning a lifecycle. And if you're still feeling a little bit weird about calling your activity a controller, I would point out in the documents, or the documentation for architecture components, they in fact do the same thing, where they refer to activities and fragments as UI controllers. And so I think it's really appropriate for the role they play in the Android environment and the special snowflake that it is. Okay, great. So we made our first upgrade. Now our lifecycle, or now our activity is a lifecycle activity. It's like, hey, look at me, I'm a lifecycle owner, but nobody's listening. Isn't that so sad? So how can we start to get our other components to be aware of the fact that this activity is saying, hey, I have a lifecycle? Well, that brings us to ViewModel. So if you remember, the ViewModel can be fetched by an activity or a fragment, and the idea is it survives through the configuration change, and it takes care of the problem of knowing when to finally release itself, and that is when the activity is finished for good. And so this also helps us answer our question of how we can scope our presenter, because if the ViewModel is able to outlive the configuration changes, then we can scope the presenter to the activity and just have it be pure logic, no state whatsoever. Now, one approach would be to just swap out our presenter and replace it with a ViewModel. But the fact that there is a ViewModel component doesn't necessarily mean you have to use MVVM or presentation model as our base architecture. We can have both, and ViewModel can be the tool that stores the state, whereas the presenter can be the tool that is just the pure logic for how to format that for display. And so how might we do this? So we want to declare a class that inherits from the base ViewModel, and it simply has a user object inside of it. Now, when we start up our activity, the first thing we're going to do, instead of creating the instance of the presenter, is we're going to say, hey, give us our ViewModel. If this is the first time this activity has started up, it's going to get a fresh one. If it is resuming after a configuration change or maybe some other event, then it's going to get a reference to the one that it had before. But then we don't actually want to do anything with the ViewModel in the activity. Remember, the activity already has a lot of responsibilities, okay? He's got a lot on his shoulders. We just hand it over to the presenter and say, here's the ViewModel I want you to use when you're figuring out the presentation. And so the presenter gladly accepts that ViewModel, as well as accepting the login controller instance, which is our interface that declares itself as a lifecycle owner. And then what we do is when the presenter spins up, remember this is scoped to the lifecycle of the activity, so this is post-configuration change, we say, all right, well, if we already have a user stored inside of our ViewModel, let's display that one. This gives us our view state consistency. Or if we don't have one, then next time we fetch one, let's make sure we store that in the ViewModel so it will survive that rotation. Now, one final note I'd like to make about ViewModels is there's actually two different base classes you can use for your ViewModels. There's regular ViewModel, and then there's Android ViewModel. But remember, we went through all these efforts to keep Android out of this side of our code base. So I would say buyer beware, use the Android view model with caution. This gives you access to the application and by nature of it a context, but then all of a sudden we're polluting the non-Android half of our code base with Android dependencies, and testing is going to become a nightmare. So I'm sure there's use cases where you have to go this route, and but just be aware of the cost that comes along with it. Okay, so now revisiting our colorful diagram, we have a view model living inside our presenter that's handed to it by the activity. And that's the thing that stores the state, and the presenter stores just the pure display logic. So the next component we're going to look at is LiveData. And if you remember, this is the observable wrapper class for our data models. And so what this is going to do is give us a nice interface that we can watch for changes that happen in the data. And so inside of our login view model, instead of just having a raw user object now, we wrap it up in an instance of LiveData. And this gives us this nice observable interface. But again, we don't want our activity getting polluted with sync logic and watching this model. We're going to let the presenter do all that. And then when it sees changes in the view model, it's going to then push those back into the activity in a very declarative fashion, a very testable fashion. And so I think the advantages here are pretty clear, and also where it fits into our diagram. Now we have a LiveData that wraps up our view model. And so the last component here that I want to talk about is our SQLite wrapper, also known as Room. Now, this gives us a nice abstraction layer that we can use around our local database components, and it really ties in nicely with the other components in that, so for one, it simplifies declaring what our database scheme is going to look like, and mapping that to our actual model becomes way easier than it was before with SQLite helper or whatever we called the thing. But one of the biggest advantages of it, well, before I get to, so one of the biggest advantages is definitely the compile time validation we have now for our SQL, but also it plugs in nicely with the rest of our architecture in that we can actually return live data objects right out of our database and put them into our view model. And so now when we revisit the view model, we can see that actually the view model itself is the piece that's going to know how to fetch this data out of the database, rather than having that in the presenter, because again, this could be a long-running operation. And so we want it in the place that stores state, not the thing that is our pure logic and is scoped to our activity. Does that make sense? I see some head shaking. Good, you're all still with me. We're almost there. All right, so then when we go back to the presenter, we can see here that this even simplifies what we need to do there, because the view model is now responsible for the fetching of the data, and we're just simply waiting for the result. And so now if we revisit our original diagram, we see now that we have Room wrapping up storage, and this is the one I showed all the way back in the beginning when you were probably like, holy cow, this guy's completely crazy. He's trying to make things more complicated than they need to be. But actually, there's really a purpose for each one of these components. And again, when you have pieces inside of your code base that do one thing and do it well, that's great for testing, it's great for maintaining it over time, it's great for evolving it as you go, and we didn't have to scrap and rewrite our app from scratch. We can introduce these pieces one at a time and get these quick wins. So if you're interested in learning more about this, I have a blog where I write about things, all things testing and other things that allow you to do better testing. Fun fact, Medium does not let you change the URL for a publication once you make it. So this started out as a very ambitious project. Don't let the daily part fool you. I do not post on a daily basis anymore, but I'm stuck with it now. And then I also have some sample code of the application we were just walking through up on GitHub. So before we wrap things up, I just want to leave you all with some thoughts for the future of where we might be going now in this new, mature age of Android development. So the first one is, I really see the Architecture Components project as a great example of what has been an effort in the community for a number of years now to bring these issues to the forefront. And so it's really a great example of Google picking up what the community has been putting down. So everybody should give themselves a pat on the back for making this one of the priorities as we move forward with Android development. I think it's also important to remember that these components are mix and match, and they're designed to be that way, and they're actually designed very well, and they do a good job of it in that you can use one, or you can use all, or you can use none, and all can lead you to a fine result depending on what your individual needs are. This also brings us to the question of where do we land with fragments, right? So fragments have first-class support in architecture components. At the same time, with architecture components, we also get a lot of tools that may make it so we don't actually need fragments anymore. And so we're kind of at this fork in the road, it feels like, where for a long time the community's been moving away from fragments. Maybe architecture components are the things that actually make them usable again, and we have a resurgence of fragment-based development. Or maybe it's the nail in the coffin, and now that we have all these tools to do it another way, maybe we just forget about them and never look back. So, who knows? On that note, I'm really excited to see, as an SDK developer and also a user, where we go with lifecycle-aware libraries, and the fact that you could have a library project that automatically initializes itself with way less boilerplate code. Maybe you could build your own navigation library that uses fragments or doesn't. And finally, you know, it's just a really exciting time to be an Android developer. We're all figuring this stuff out together, and the fact that the community has put these issues out to the forefront, we've made a lot of progress, but there's still a long way to go. So if you saw anything today that you're like, I have a better idea on how to do that, I'd love to hear about it. And at the same time, maybe you saw something that you have a new idea that you want to try when you get home. So either one is great, and hopefully we all got some of the both. So that's everything I have. Thank you for coming. Now, I know you're probably all in a hurry to get over to Spark Social and start enjoying the party. So do we have any questions here, or I could also take them offline around a fire pit? Yeah, one question. Can you just use the mic in the middle here?
Yeah, so I was wondering what kind of tests you're running around the repository component?
Good question. So I'm not actually currently using a repository, so I'm not writing any tests around it. So that was like one of those enhancements. Let me go back to the diagram here. That was one of the enhancements that I added, is like this would be a good idea if you had a use case that was fetching network resources and also storing them locally. I know there's a popular repository project from the New York Times, right, called Store. And I would look there to see the way that they approach testing, because I could give some recommendations, but mine would be like made up off the top of my head, where they've actually spent a lot of time solving this problem and probably have a really good approach for it. Yeah?
What's the project that you just said for testing samples? New York Times?
Specifically for a repository implementation, there's a project from the New York Times called Store. Store, yeah.
So I'm kind of curious to know why you have the ViewModel. You chose to have the ViewModel inside the presenter. Let's say if you want to have some view logic in it, would you put that in presenter or would you put that in ViewModel? Like, is there kind of confusion around it?
So for me, good question. So the difference, why would I put the ViewModel in the presenter? And the way that I tend to look at it is the ViewModel stores the current state of the UI, and the presenter is just pure logic that is around how to format that. Let me give another example. So for example, another app that I wrote when I was playing around with this stuff was a calculator app where you added two numbers together, and then I wanted to display positive numbers as green and negative numbers as red. And so the ViewModel stored what was actually displayed on the screen at any one time, but the logic to decide whether or not how to color code it is what I put in the presenter.
Hi. Hi. So right now, this is kind of assuming for like you want to put all this stuff in an activity. If you wanted to be like a little more granular, like let's say you had like a fragment, could that be applied to that too? Would that be appropriate? Or even further, like into a custom view and have all those different things in there?
Sure. So if I understand the question correctly, could we like replace our activity with a fragment here and still build the same scaffolding all around it, or even a custom view?
Yeah, like let's say the activity is very complicated and there's like probably isolated components on that screen. Would that be appropriate to do all that for each one, or?
I would say definitely, like every one of your fragments could have their own presenter and could also access the same or different repositories. Also with custom views, I've definitely built presenters in those as well in a compound view. Just if they get more intricate and have presentation logic that is associated just with that view, then sure. You could have that play that role as well and implement that controller interface.
Okay, and then the new architectural components it would work in those scenarios.
It would definitely work with the fragments. The views, I'm not sure because they don't broadcast the same lifecycle events as activities and fragments. So yeah, good question. I'm not sure how that would play out. All right, we'll do one more, and then we're heading over to the food trucks. Yeah, that's quite all right.
Quick question: what are your views on possibly using a event bus, combined with the controller? Combined with the controller in order to facilitate using fragments if you need to keep state on multiple fragments or update them all at one time?
So I've definitely used, and a good question, I've definitely used an event bus in an architecture similar to this, but the way I used it was actually as a back channel to allow my presenters to talk to each other. So I didn't use it on the view side, but that was how I propagated any data that the presenters all needed to know about. Like if there was an event that was going to affect multiple views and I wanted multiple presenters to hear about it, I would do that through the event bus. Yeah. Thank you everybody so much for coming. I'll see you over at the party.